Okay, now let's convert fractions back into decimals. Let's do a simple example, half. One way to do this, and this is probably the most popular way, is to do long divisions. If you have 1 divided by 2, there isn't a 2 in 1, so you introduce a decimal. So you can times that by 5 to get that 1.0. So the answer is 0.5. For certain ones it's pretty simple, but for others this can get actually pretty complicated. Although some of the fractions you have no choice but to do it this way. So what I want to talk about now is which ones can you do it faster, which ones you have to use this particular long division method. Okay, so we saw that from decimals, right? From decimals to fractions, it was very simple. If you have a decimal, let's say 1, 2, 3, all you do is to just put the 1, 2, 3 and put 1 with that many zeros. And vice versa. If this was a fraction that was given, it's very easy for you to convert it back into this form. So here's what I suggest. If we have some kind of fraction, right? A fraction is given. Why don't we turn it into this form first so that we can easily convert it into a decimal? For example, half. I can turn it into this form by multiplying the top and bottom by 5. I have to do that equally to top and bottom, so that really I'm just multiplying by 1. This is the value of 5 over 5 is 1. And the reason why I'm multiplying top and bottom by 1 is I want a power of 10. So 1000 is a power of 10. How do I make a 10 with 2? Just times it by 5. Done. This is 0.5. Let's do one more example. Let's say we have 1 over 4. Okay, instead of doing the long division, well, how do I turn this, right? How do I turn this into a power of 10? Well, 4, okay, let's actually do this first. 4 is 2 times by 2. Every time, if you want to make a 10, you know that 10 is actually 2 times by 5. We have 2 2's here, so how many more 5's do we need to create 10's? Well, 1, 2 5's. 10, 10, that's 100. The top gives you 25, so it's 0.25. Okay, let me just do one with 1 over, let's say, 25. This is 1 over 5 times by 5. I'm breaking it down like that because that tells me how many more 2's do I need. I need 2 of 2's. 10, 10. Once again, 100. Top will give you 4, so it's 0.04. So essentially, if you have a fraction with the factor of 2 and 5, so 4 has only factors of 2, 5 has prime factor of only 5, these such fractions can be used, we can use this particular procedure to get to, right, to get to the decimal faster. Imagine, compare this example here. Imagine doing that with long division, 1 with 25. It would take a little bit longer than doing it this way. Right? You have to go, oh, that 0 doesn't work, 0 doesn't work, and you have to put a 4 there, right? Oh, and then it's 100, right? You know, for that one, it took about, I would think it would take about the same time. But generally, I mean, you ask yourself, do you like multiplication better or division better? I personally find multiplication a lot easier, and I like doing things the easier way. To illustrate really why this method is better for fractions with factors of 2, prime factors of 2 and 5. So let's do 1 over, let's say, 20. Okay, 1 over 20. So let's make it even tougher. 7 over 20. So imagine doing long division with 7 over 20. Here's what I'm going to do. I'm going to ask myself, how can I turn 20 into a power of 10? Well, I know that a 2 paired with a 5 makes a 10. 20 is 2 times by 10, so I already have 110. I just need an extra 5. So I get 35 over 100 and 0.35. Okay, so I hope that example convinced you that for these type of example, it's faster to do it this way rather than doing through long division. So what about the other ones? What about if it contains 1 over 7, not a factor of 2 or 5? Such cases, right, we have to rely on long division. Right, so you will do this. 1 gives you 0.7, 30, 4 times 7 is 28, 2, right, 2 gives you 14, and then 7, and 6. Okay, bring the 0 down again, and you get 4 if you subtract that, right? And then you think about, look how long this is, right? For these kind of examples where the numbers are like this, 7, like 11, they're going to be ugly. Okay, let's keep going to, let's see if we can finish a pattern here. 5 gives you 35. So if you subtract that, you get 5. So it's 50 now. 7 times 7 gives you 49, gives you 1. Okay, now we're back here. Okay, so the next one is going to be 1, 4. The pattern will repeat. 1, 4, 2, 8, 5, 7. So this is actually 0.142857. So for such examples, we have no choice. We got to use long division. For ones. Okay, so 1 over 3. 1 over 3, if you follow the same procedure, you get 0.33333. So you write that as 0.3 bar. So what happens if I have 1 over 6, which is 2 times by 3, which is half of 1 over 3. Then that's going to be literally half of the decimal 0.3333, and this might be a little bit confusing. So let's just actually divide. What happens if you do 33 divided by 2? Right? That's what this is. This is 0.3333 divided by 2. Then you get 1, 13, right? And you would say 16, or 6, so you get 12, and you get 1 again. 3, we bring the 13 down again. You can see the pattern is going to be this. Okay, so we can, you don't have to go through the process of finding this every single time. 1 over 3 is pretty useful, so you should just memorize that repeating decimal. Okay, and you can just write down 0.1666 and so on. Okay, let me give you even a more useful example. What about 1 over 9? Okay, 1 over 9. That's right. That's a third. That's a third of 1 over 3. And you can think of this as this is a third of 0.333 and so on. So that's same thing as, right? That's same thing as dividing all of these 3 by 3. So it's going to be 0.1111. So 1 over 9 is 0.1 repeating. So this, these two are a little bit more advanced. It's more advanced thinking, right? But try to use them. Try to use this particular thought process to convert some of the fractions without using long division. If you get really stuck, try it. But come back and just, if you have some time, think about it if you can do it in this kind of using this kind of method.